Hello friends, welcome to my channel. This is Objective Mechanical Engineering. In this video I will cover Objective Mechanical Engineering Part 1. These videos are useful for RRB, IES and PSU examination, and this is useful for State Public Service examination also, and useful for SSC JE also. Question is, logged chain satisfy equation I n equal to 2p minus 4, equation double I j equal to 3 by 2 n minus 2. Options given. Equation 1 is n equal to 2p minus 4. We can write it as 4 equal to 2p minus n. And equation 2 is j equal to 3 by 2 n minus 2. We can write it as 4 equal to 3n minus 2j. Here n is number of links, p is number of pairs and j is number of joints. Here 4 is left hand side and 2p minus n is right hand side, like this. This is LHS, this side, right hand side. 4 conditions are there, 3 conditions are there. In condition 1, if LHS is greater than RHS, it's not a kinematic chain. It is called as rigid frame or rigid structure. No relative motion is possible. It is also called as locked chain. So, if you take a structure like this, 3 links are there, 1, 2, 3, 3 links are there and having 3 joints. Then we will check for these conditions. Here 3 pairs, number of links also 3, number of joint also 3. So first we will check for this one. 4 equal to 2 into number of pairs is 3 minus 3. So its value is 6 minus 3, 3. LHS 4 is greater than 3. So LHS is greater than RHS. So it's an example of structure. It's a structure or locked chain. Condition is LHS is greater than RHS. In second condition, if LHS equal to RHS, then kinematic chain with 1 degree of freedom will possible. It is called as constraint kinematic chain. For example, if we take 4 links, 1, 2, 3, 4, then we will check for the conditions. 4 equal to 3n minus 2j. So number of links n is 4, number of joints also 4. 4 equal to 3 into 4 minus 2 into 4. 12 minus 8 is 4. So LHS equal to RHS. So it's a constant kinematic chain. 1 degree of freedom is possible. Next, third condition is if LHS is less than RHS. This is the equation. If LHS is less than RHS, then it's not a kinematic chain, or it is called as unconstrained chain, or relative motion is not completely constant. For example, if we will take 5 links, then we will check for this condition, n equal to 5 and j equal to 5 here. So we will get here 5 and LHS is less than RHS. So this is the example of a unconstrained chain, or here relative motion is not completely constant. In this question they asked for locked chain. For locked chain condition is here LHS is greater than RHS, but option A only equation 1, no, not possible. B only equation 2, not possible. Satisfies both the equation, not possible. Does not satisfy both the equation, this is possible. For locked chain LHS is greater than RHS. So here in both equation LHS is equal to RHS, in 2 also LHS equal to RHS. So does not satisfy both the equations for locked chain. Option D is our answer. This type of question they are asking in GATE examination also. You will get in GATE IS also they are asking this type of questions. Then next question, roller bearing is a option A spherical pair, B higher pair, C lower pair, D cylindrical pair. First I will tell about higher pairs and lower pairs, then we will answer this. For higher pairs there exists line contact or point contact between them. Examples are cam follower, wheel rolling on a surface, two-thread gearing. This one also asked in GATE. For IS also so many times they are asking. So this is very very important. Then ball and roller bearing, this one asked in this question. Belt and pulley, rope and drum. Belt and pulley also very very important. Cam follower also important. So roller bearing is a example of higher pair. B is our answer. Then for lower pair there exists surface contact and area contact. Examples are pin joint, or we can call it as revolute joint, knot turning on screw, shaft rotating in a bearing, all pairs of slider crank mechanism. This is also asked in IS. And universal joint, this one also asked in IS. Not turning on screw, this one also asked. So all options are important. Next question is, one of the following mechanism is not exact straight line mechanism. So we have to check this one. Straight line mechanism examples are Scott-Russell mechanism, then Peaucellier mechanism, Hart's mechanism, and for approximate straight line mechanism, Watt's mechanism and Grashofer mechanism. In this question they ask not exact straight line mechanism. So option is this one, Grashofer mechanism. A is our answer. One more thing is important here. Here all mechanisms are example of lower pairs. Lower pairs. Scott-Russell, Peaucellier, Hart's mechanism, Watt's mechanism and Grashofer mechanism, all four are example of lower pairs. This is also important. Which of the following is an inversion of single slider crank chain? A. Hand pump, B. old arms coupling, C. Scotch yoke, D. elliptical trammel. So single slider crank chain. single slider crank chain. So here this red color is body or frame, link 1, then link 2 is crank, then link 3 is connecting rod, then slider is link 4. This is example of single slider crank chain. Its inversion we have to use. Hand pump is the fourth inversion of single slider crank chain. In hand pump, you have to fix the fourth link. So it will come this is link 2, hand pump is our answer. In hand pump, the link 4 is fixed. Here this 4 link is fixed. Is link 4. This is slider. Slider is fixed here. And B, C, D all are examples of double slider crank chain. Double slider crank chain. It's like this. Two sliders are there. On connecting rod. So here inversion of single slider crank chain as example is hand pump. Its fourth inversion where fixed link is link 4 or slider is fixed here. Size of gears is usually specified by A. Circular pitch, B. Outside diameter, C. Pitch circle diameter, D. Inside diameter. Its answer is pitch circle diameter. Then circular pitch, it's pi d by t. This is also important. So many times asked in IS and ISRO also they are asking this type of question. And module M equal to d by t and diametral pitch is t by d. All three are important. So many times asked in ISRO and IS. And other PSC also they are asking. So this is very important. One of the following is not pure rotation. It's not pure rotation. So options are A. Windmill, B. The minute hand of a clock, C. Bicycle wheel, D. Flywheel. Its answer is the minute hand of a clock. B is our answer. It's not pure rotation. Knee joint of a human being has dash degree of freedom. This is very important. So many times asked in IS and other PSU examination also this one asked. Knee joints are also called as pin joint or revolute joint. Two links are there. They are joined like this. Link 1 and link 2. only delta theta is possible. So 1 degree of freedom possible. Example of lower pair. This is also important. So knee joint of a human being has 1 degree of freedom. The frictional torque transmitted by a plate cord is same as that of frictional torque transmitted by a plate close. So TF equal to mu W R effective. It's same as flat collar bearing. From option B is our answer. So for uniform pressure theory, R effective equal to 2 by 3 RO Q minus RI Q divided by square. Uniform wear theory, 1 by 2 plus Ri. For conical pivot bearing, this one asked ISRO 17 paper. The tractive resistance during the propulsion of a wheeled vehicle depends on A. Road resistance, B. Aerodynamic resistance, C. Gradient resistance. Tractive resistance during propulsion of a wheeled vehicle, it depends on all. Road resistance and aerodynamic resistance, gradient resistance. All of these are answered. The size of gears is usually specified by, this one already discussed, pitch circle diameter. In a riveted gear train, the axes of the first and the last gear are, this one also asked in ISRO 2017 paper. In a riveted gear train, the axes of the first and last gear are, I will draw the figure. This is gear 1, then gear 2, then gear 3, they are in same shaft, then gear 4. This is fourth gear. 1, 2, 3, 4. 2 and 3, they are in same shaft. Fourth is our last gear. So in riveted gear train, the axes of first and last gears are, they are coaxial. B is our answer. And for parallel case, spur gear, 2 spur gears, if they will connect, gear 1 and gear 2, their axes are parallel. And for perpendicular, bevel gears, gear 1 and gear 2. Their axes are perpendicular. but in this case they asked reverted gear train. So first and last gear are coaxial. Here 1 and 4 both are coaxial. For neither parallel and nor coaxial hypoid gears, they are example of neither parallel and nor coaxial. Thank you friends. Thank you for watching my video. Thank you.